Google DeepMind has just rolled out their brand new Gemma 3 models. These models build on a lot of the same research that went into the Gemini series, but they're designed to be super light, nimble, and easy to deploy on a single accelerator, whether that's a GPU, a TPU, or even some other hardware like AMD GPUs or a Jetson Nano. They call it the most capable model you can run on one device, but it still packs a major punch when it comes to performance. The reason it's getting so much buzz is that it brings a mix of advanced text and visual reasoning capabilities, has built-in support for over 140 languages, and even handles a massive context window of up to 128,000 tokens, which is seriously big for an open model. But also lately, we see it becoming a norm now. Part of what makes Gemma 3 special is that it's not just about text anymore. We're talking true multimodality here, so you can actually feed it images, short videos, or text, and it'll pass those inputs like a pro. It's using a vision encoder technique called SIGLIP, which has a frozen 400 million parameter vision backbone that converts images into a series of 256 visual tokens. These tokens then get fed into the language model portion, letting Gemma 3 respond to questions about pictures, identify objects, or even read text that's embedded in an image. One of the helpful things they introduced is a so-called pan and scan trick that cuts up images into smaller crops to preserve detail, especially when dealing with non-square formats or images that have text in them. It helps preserve all that sharpness without stretching or squashing the image into a one-size-fits-all shape. They've released Gemma 3 in 4 sizes: 1 billion, 4 billion, 12 billion, and 27 billion parameters. By B, I'm referring to billions of parameters, of course. The biggest one is the 27 billion version, and it's the star of all sorts of comparisons. In fact, they looked at how it scores on the LMS chatbot arena. This is a platform where human raters do blind side-by-side comparisons, producing something called an ELO rating. Gemma 3 27 billion ended up with an ELO score of 1,338, which puts it way above older open models like DeepSeek V303 Mini or the 405 billion membership version of Llama 3. The ELO scores make it super clear that although Gemma 3 27 billion is relatively small compared to some of those massive 70 billion or 400 billion or even mixture of experts models, it competes seriously well in terms of user preference. Interestingly enough, Gemma 3 introduces a pretty different architecture under the hood to reduce that massive memory overhead you often see when you push context windows toward 128,000 tokens. The big trick is that it uses a bunch of local self-attention layers interspersed with fewer global layers in a ratio of around 5:1. So, you might do local self-attention for 5 layers, then global attention for 1, and so on. This drastically reduces the memory footprint because not all layers have to attend to the entire 128,000 tokens. For local layers, they're basically working with a sliding window of 1,024 tokens rather than 128,000. And that means your KV cache doesn't blow up. The result is that you can have ultra-long context without requiring an insane system with dozens of GPUs just to hold the memory. They've shown that by using 5:1 local to global layers with that 1024 sliding window, you cut memory overhead to around 15% instead of something like 60% if every layer had to be global. Another new thing is that they're shipping Gemma 3 with official quantized versions. Quantization means taking all those 16-bit floating point weights and compressing them down maybe into int4 or some special float 8 representation, so the models fit into much smaller memory footprints. They do a short round of quantization-aware training and knowledge distillation, which helps preserve the model's accuracy, even though it's using fewer bits. Quantization is huge for running these big models on smaller hardware, so that's a big plus if you don't have an ultra-high-end GPU or if you want to host it on, say, a CPU in certain situations. Now, Gemma 3 still uses the same sentence piece-based tokenizer as Gemma 2.0, with 262,000 vocabulary entries to cover 140 languages. They rely on knowledge distillation from bigger teacher models, though smaller teachers can work for short training runs. The model also supports function calling and structured outputs, so it can natively generate JSON or run function signatures without hacky prompts. They carefully filtered training data, applied reinforcement learning from human feedback, and tested the models for memorization risks or personal data leakage. They found low violation rates and minimal advanced harmful capabilities. Despite these safeguards, developers must still handle safety responsibly when deploying open models like Gemma 3. On the hardware side, the official line is that Gemma 3 has been optimized for NVIDIA GPUs, Google Cloud TPUs, AMD GPUs via ROCm, and for CPU execution with something called GMA. If you're on an NVIDIA system, you'll appreciate that they've got direct optimizations from the Jetson Nano to the top-tier Blackwell chips. It's even featured in the NVIDIA API catalog, so you can do rapid prototyping from there. Meanwhile, if you prefer running everything in the Google Cloud, you could spin it up on Vertex AI, on Cloud Run, or through the Google Gen AI API. And if you just want to toy around with it on your local machine, you can download the weights from Kaggle, Hugging Face, or Ollama. Now, one more piece that came out simultaneously is Shield Gemma 2, a specialized 4 billion parameter image safety checker that uses the Gemma 3 architecture. It'll let developers scan images for 3 categories of content: dangerous stuff, sexual content, or violence. So, it's basically an out-of-the-box solution to keep your pipeline free of images you don't want in your dataset or user feed. You can further customize that if your personal or regional guidelines differ, which is a big plus for developers who want to tailor it to their own safety standards. And since it's built on the Gemma 3 foundation, it should run efficiently on the same hardware or frameworks that you're already using. The other big push is an academic program around Gemma 3. Google DeepMind is offering $10,000 worth of Google Cloud credits to academic researchers who want to do serious research with these new models. That application's open for a few weeks. So if you're in academia and want to harness a 27 billion parameter model for something new, that might be an awesome opportunity. They're talking about fueling the so-called Gemmaverse, that broader ecosystem where thousands of variations of Gemma have popped up in the past year. AI Singapore's Sea Lion V3 and Nexa AI's Omni Audio are just a couple of examples they mention, where the open nature of Gemma models has let people build really specialized derivatives for everything from language translation to advanced audio processing. The technical report that came out sheds a lot of light on how they tested Gemma 3. They mention standard benchmarks like MML, Live Code Bench, Bird SQL, Math, and a variety of multilingual tasks. The 27 billion instruction-tuned version of Gemma 3 is in the same performance league as the best open models. One chart in the technical report shows it's even on par with or above older Gemini 1.5 in certain tasks. They rely on improved post-training or instruction tuning that uses a multi-step approach, mixing advanced knowledge distillation from a large teacher model plus reinforcement learning methods that incorporate code execution feedback. This approach is what drives up the performance on math coding, reasoning, and conversation. They also tested more intensively around vision tasks such as Doc Vukwa, Info VQA, and Text VQA, demonstrating big improvements when you properly handle images at a higher resolution with that pan and scan method. Some tasks saw a big jump after you apply PNs, which is nice for reading text out of images or dealing with complicated aspect ratios. Of course, they do emphasize that if you want to use these models or their code, you can do so via your favorite frameworks. If you like Hugging Face, you'll find Gemma 3 there. If you prefer JAX, Keras, PyTorch, or VM, you've got that option. They're also shipping new recipes and code bases for training and inference. So if you want to do your own fine-tuning, you can. That includes a function calling workflow, structured outputs, and the ability to handle 128,000 tokens of context. They say you can run it in your local environment if you've got a decent GPU, or do it on the cloud if that's your style. They're just trying to make it super flexible for a wide variety of use cases. They've also indicated that these new Gemma 3 models are trained responsibly, which means they try to follow a risk-proportionate approach. The more powerful the model gets, the more they evaluate it. Gemma 3 apparently got a specific check around misuse for making harmful substances, and they concluded the risk was low. They also are continuing to refine their approaches, so presumably, with each new version, they'll improve. Since the last iteration of Gemma launched, there hasn't been any big example of malicious usage, so they think that risk remains quite small. Alright, that's a wrap on Gemma 3. I'd love to hear your thoughts in the comments. If you enjoyed the video, don't forget to leave a like. And if you're not already subscribed, now's a great time to join in. Thanks for watching, and I'll see you next time.